Reading an encoder with pysimCoder and NuttX is straightforward. We'll be using the encoder block under the NuttX tab. At Robots5, we offer rotary and linear encoders. To start, I'll plug our EMB SM1 rotary encoder module to the EMB DAC1 encoder connector 1. In pysimCoder, we bring an encoder block, a gain, and a UDP block. The encoder 1 of the EMB DAC1 is configured as QE2, and the encoder 2 as QE3. The resolution of our rotary encoder is 2048 counts per revolution. A gain block can be used to get the appropriate units. This value depends on how it was configured in NuttX. For this particular case, to get an output in radians, our gain is pi. Now we can change the template make file to NuttX, save the model, generate code, and flash to the target. To visualize the data, we use the RTScope application. The linear encoder works the same way. I'll remove the rotary encoder and plug the linear encoder into the same connector of the DAC1. In pysimCoder, I'll change the resolution to 2000 as we get 2000 lines per inch, and change the gain to 12.7 so we get an output in millimeters. Note that these are incremental encoders, and the 0 position is set when we run the code. Here we have a more dynamic plant, with a spring, a dashpot, and a pendulum. Both encoders are used to capture the motion.